Okay, let's take a look at question 1 part 1. So we have to, what is the question asking? Differentiate this guy. So 2x times e power 1 minus 2x, right? So let's see what happens. Over here there's a coefficient 2, so we can factor it out first. So we get 2 times of the derivative of whatever remains. What do you see here? It's a product of two things, one and the other. So remember your product rule, take one, differentiate the other, plus product rule, you link it with plus sign. Remember, quotient rule, divide, you link it with a minus, right? Low D high, less high D low, draw the line and square below. Of course, this is a product, so use product rule, which says one, the other, plus, take the other, the one. Good, so proceed. We get 2 times, draw a huge pair of square brackets, take one, differentiate the other. This is e power something, so you leave it alone, multiplied by y negative 2, because here there's a inner function. E power something is the outer function, so we're using what rule? Chain rule. Differentiate e power something, get back the same thing. Inner function you differentiate, you get negative 2. Plus, take the other, multiply by, differentiate 1. Differentiate 1, what's 1? X, right? Differentiate and you get coefficient 1. Okay, good. Bring the bracket in. 2 times, let's simplify this. You have negative 2 times x, it's a negative 2x e power 1 minus 2x. This is 1 times something, so it's just e power 1 minus 2x. Anything common? Yes, e power 1 minus 2x is a common factor, so we can factor it out of the bracket. We are left with minus 2x plus 1. Okay, good. Let's make it look a little bit cleaner. This one is 1 minus 2x. Right, good. But that's nice and all, but is it useful for us in part 2 when you have a product going on? We need x times e power 1 minus 2x on its own, right? So the answer is no, not really. So it's better, even though this is fine, this answer is also fine, that answer is also fine, I would do one more thing, because I know this is a 2-part question and I need to use part 1. I'll be a bit more strategic with this line over here. I will rewrite it in the following way. I will multiply the 2 into each of the terms. Let's see what happens. So 2 times a negative 2, you get negative 4 times x times e power 1 minus 2x. And then you have 2 multiplied into the second term. Oh, where's my highlighter? 2. Okay. Is the battery flat? Oh my goodness. Give me a second. Okay. I think you get what I'm saying. The 2 you have to multiply into the second term, which is the e power 1 minus 2x. So what I mean is over here, multiply into the second guy. So you end up with plus 2 times e power 1 minus 2x. Okay, good. So let's rewrite it neatly. Okay, remove the arrow. And write it like this. So derivative of that expression equals to whatever we just found. Okay, good. So now we can move on to part 2. So always make use of part 1. Remember that integration is the reverse of differentiation. So here's a neat way to present it. You can copy and paste the entire expression. I'll give a bit more space. Then you integrate with respect to x on both sides of the equation. What happens when you do that? The integral and derivative will essentially cancel away. You're left with 2x times e power 1 minus 2x equals to integrate this, but there's a plus going on, so you can integrate term by term, which is what I was telling you, right? Integrate negative 4 times x times e power 1 minus 2x dx plus integrate 2 times e power 1 minus 2x dx. Good. Notice something. Let's look at part 2 again. Copy and paste it here in case you cannot remember. This guy, that guy looks very similar. Why is it similar? Because there's a x multiplied by e power something. X multiplied by e power something. Compared to this second guy, it's just e power something. There is no x. Definitely not the same as this guy, huh? So we should be comparing this final answer that we want with this part of the answer on the right hand side. So what's the coefficient that's required? Positive 2. So maybe if you can just leave the positive 2 alone. Like this. Notice that negative 4, you can factor out a positive 2. What are you left with? 2 times what? Gives you negative 4. Must be a negative 2. Like this. Okay? Plus the integral 2e power something something dx. Copy and paste. Left hand side stays the same. Good. So now you want to have this, this as the subject, right? So how about we do the following? I'll delete this. Make this guy a capital X temporarily. Okay? So essentially, if you see the pattern, it's negative 2 times x plus a happy face, the integral of this guy, replace it with a happy face, equals to, I'll just copy and paste the left hand side like this. Can you make x the subject, the capital X? Yes. Yes. Capital X in this case will just be whatever we had on the left hand side, subtract away the happy face, divided by negative 2. Okay, good. So what is that happy face and what is the x? It's really just the integral, what is the x first? It's really just the integral of 2x times e power 1 minus 2x dx. And on the right hand side, you have 2x times e power 1 minus 2x, minus away the happy face, which in this case is integral of 2 times e power 1 minus 2x dx, all divided by negative 2. Okay, good. Problem. Oh no, there's still an integral in a fraction. But can we calculate this? Can we evaluate what this is? Yes, let's do it at the side to save some space. Integral 2e power 1 minus 2x dx. Let's see. So I can factor out the 2 first so that the coefficient is always a 1. Right? So 2 times the integral of this guy, e power something. What do you do? My favorite integral to do. Copy and paste only. Don't need to think so hard. But because there is a coefficient negative 2 here, remember if you're doing differentiation, you have to use chain rule because there's an inner function 1 minus 2x. You end up, at the end of the day, you have to multiply by a negative 2. But here, because we're doing integration, which is the reverse of differentiation, so instead of multiplying by negative 2, what do? You divide by negative 2. Okay, that's your answer. You can verify that this answer is correct by differentiating on your own and check that the derivative will be e power 1 minus 2x. Just use chain rule. It will cancel, the negative 2 will cancel away. I'll leave you to do on your own now. I will skip the plus c. Okay, eventually the 2 cancels away here and there. You're left with negative e power 1 minus 2x. Okay, I'll put a plus c to be accurate. Fine, plus c. This guy is the answer to integral of 2 times e power 1 minus 2x. So I can just replace it over here. But be careful, pair of brackets, like this. There's still a minus sign outside this pair of brackets, so you need to multiply in later. Negative sign multiply into this guy, but this guy is negative e power 1 minus 2x. Minus minus then becomes a plus. Exactly, good. So that means that we end up having this guy, but you replace the expression in between the red brackets with minus e power 1 minus 2x. Okay, good. That means we can carry on. 2x e power 1 minus 2x. Minus minus becomes a plus. E power 1 minus 2x, all divided by negative 2. Okay, good. Let's just split it up. Let's split the fraction up. So 2x e power 1 minus 2x divided by negative 2 plus e power 1 minus 2x divided by negative 2. Okay, good. Anything to cancel? Yes, 2 and 2 cancel away. You're left with minus x e power 1 minus 2x. The other guy, plus 1 over negative 2, so that's really just minus 1 half. Minus 1 half e power 1 minus 2x plus c. Okay, good. But we are not done yet, because what did we actually want to find? We actually wanted to find the definite integral, right? The definite integral of 2x times e power 1 minus 2x dx over here from 0 to 1, right? So the next line, what we need to do is to copy this expression, but replace the lower and upper limit with 0 and 1, and then we just have to copy the expression over there. You don't need the plus c anymore, because when you sub in the upper limit, sub in the lower limit, the c will tag along in both cases, but you have to put a minus in between, so the c will cancel off the c, and that's why we don't need to write the c anymore, right? I showed it before in a previous lesson. So x equals to 0 and x equals to 1, like this. You can drop the plus c, don't need any more. Okay, good. So you sub in x equal to 1 and x equals to 0, and you are essentially done. So let's just do it. Sub in the upper limit first. Minus away, sub in the lower limit. So 0 times e power 1 minus 2 times 0 is 0. Minus half times e to the power of 1 minus 2 times 0, which is 2 times 0, which is really just 0. Good. Then simplify a bit. 1 minus 2, negative 1, e power negative 1. You have minus 1 times e power negative 1, like this. Good. Minus half times e power 1 minus 2 times 1, that's minus 1. Good. Minus away, bracket. This is 0 times something, so e power 1 minus 0 is actually e, but it doesn't really matter because you have a factor of 0 in front. 0 times anything is just 0. Good. So here you have e power 1 minus 0. Oh, is it 0? No. E power 1, right? E power 1. So it's not 0. It's minus half times e power 1. Don't need to write the 1 anymore. 0 minus half e, what does it mean? It means you have to distribute the negative in front of the second pair of square brackets. But of course, when you have a 0 minus, okay, you don't need to write down the 0 anymore. You just need to multiply the negative in. So you end up with a plus half e. And for this other guy in front, it's just minus e power negative 1 minus half e power negative 1. Okay, very good. So what we have over here, minus 1 apple minus half a apple, where the apple, my apple looks a bit weird. My apple looks like this. My apple is e power negative 1. Okay, so if you subtract 1 apple and then you minus half an apple, how many apples left? Exactly, minus 3 over 2 apples. But of course in exam you don't actually draw apples. You replace it with e power negative 1. Okay, yeah, e power negative 1 plus half e. Good. And just to clean things up a bit, I don't like negative power, so I'll just bring it down. So negative 3 over 2e plus half e. So question, is it okay if I put down half e like this? E at the bottom? No, not the same. This half followed by a e at the side where the fraction symbol is sort of in the middle. It bisects this e, cuts it in half. Means that the e is actually on the numerator. So it's actually e over 2. This is exactly equivalent to e over 2. Okay, so that means we actually need e over 2. If you want to add into one single fraction, you still need to multiply top and bottom by e, right? Sorry, battery flat. Give me a second to charge. Okay, so what was I saying? Yes, when you have fraction plus fraction, make what the same? Make the denominator the same. Here we got 2 times e, here we got 2 only, so you have to times e top and bottom. Continue. What do you get? 2e all at the bottom as one single fraction. minus 3 plus e squared. If you want, you can always swap the position, e squared minus 3. Wow, get to save one plus symbol. Save pen ink. Okay, and then we are done. You actually have to end up rewriting it, so how much ink do you actually save? Both are acceptable. Both are acceptable. Okay, that's it.